Okay, so yeah, Emma. Correct. No, we are going to finish up. I think is it 6.4 with circles, and then do the volume and surface area bit out of 6.5, and that's it for today. The what I wanted to talk about was that the test. Let's see, yeah, the test will open today. I don't remember if it opens after class or if it opened already. And it will remain open until Tuesday at 11:59. So you do have plenty, you do have like 5 or so days to get it done. And let me check. Geometry, select, where's preview? There we go. Oh wait, no, I don't want to do that because then everybody will see. List some questions, maybe. 25. So I don't think I timed it. Let me, assignment manager. Yeah, no, I don't see it timed here. Right, 5, 11, 12, 15, 18, 23. Yeah, 25. So I've got 25 questions. I've got no specific time limit on it. I believe you can go back and forth. Settings for class. Let me just review my settings real quick to make sure. Because, I did this last week when I wasn't particularly focused. You have 2 attempts at it. You can start it and stop it. My caution with starting and stopping is that you cannot, once you stop, let's say, for example, you, let's say you do the first 7 questions, right? And then you have to stop and go do something else because you have to work or you got to walk the dog or a kid got upset, whatever that may be. When you return to the test, you can't get to those 7 questions anymore. Does that make sense? Yeah. So if you've attempted or opened a question, if you walk away from the test, you're not going to be able to get back to those questions. So be careful about jumping around and all the rest. Okay. You do get 2 attempts though. So if it gets totally screwed up on the first attempt, you do still have a second attempt at the test. Okay. No, it does not. And I don't think, well, yeah, I'll take a look at it and see if there's a show work option. I can't remember if there is on my lab. I know there is on Cengage, but I don't remember there being a show work. Time allowed. Nope, I didn't time it. Move points, study plan. I don't see a show work. Yeah. I do have partial credit though if there's multiple parts. So that part's all right. But okay. All right, let me get out of that. Leave. I didn't make any changes. All right, let me get out of here. We'll do this. There we go. All right, is my music too loud? Can you even hear that it's in my, that I got it going in the background or not? All right, then I'm not gonna. Well, I'm not gonna be too concerned about it then. It's not. There we go. Okay. So we've got to finish 6.4, and then we're going to do 6.5. 6.4 is some of the formulas for the perimeter and area of a circle. And then 6.5 is three-dimensional shapes, volume, and a little bit of surface area. So as we get started, I just want to make sure that everybody is clear and okay with the different vocabulary on a circle. A circle is defined as a set of points on a plane that are always equidistant to a given point known as the center. So the circle itself is the outside or the perimeter. This is the circle. Oh, well, that's not helpful. Is that better? Okay. It just didn't like that, I guess. When I went full size. Just didn't like that at all. Okay. So the circle is the set of all points all the way around. I mean, we tend to think of the circle as like this full shape, but the circle is actually just the circumference. They all have to be equal distance to a center. So this is what gives us the different parts. The radius of the circle is that equal distance. So the distance from this center to any point on the circle, no matter where it is the radius. So all of those little orange lines have to be the same. They are all radii and they are all equal. If you put two radii in a straight line, back to back, you have what's known as the diameter. The diameter will always be the length of two radii because you will have a radius to the left and a radius to the right. The perimeter of a circle is known as a circumference. It is the distance around the circle. All right. Now, circles have this magical number associated with them called pi. Pi, spelled Pi, and written with two straight lines and sort of a tilde on the top. And depending upon your font on the computer, many different variations, but always sort of looks like a double T or a double capital T. It's been years, and by years, I literally mean ancient Greeks, 300 BC. Noticed that no matter what they did, if they took the distance all the way around the circle and divided it by the distance through the circle, So if they took a circumference and divided it by the diameter, they always got this number that was close to 3.14. Now, as we worked through all this stuff, we realized that it's actually an irrational number, 3.14, 159, 26, and I don't even know all the numbers. There's a gentleman that has, like, I don't know. There's a guy called Daniel Tammet. He has synesthesia. I don't know if you know what synesthesia is, but synesthesia is like when you can, you see colors with numbers, or different letters have like a taste. They evoke like a taste in your mouth. Basically, your senses get sort of confused. But he has synesthesia, and he sees colors for his numbers. Every number evokes a color for him. But he's an autistic savant in like the old form of that particular phrase. He sat for over 8 hours and recited the decimal places of pi. Like 3.141592 and he kept going with all the numbers for over 8 hours. And he didn't miss one. This is irrational. This is known as an irrational number. You guys probably know pi as just 3.14, right? This is an approximation. It is not really 3.14. Most people in mathematics or engineering use 3.14159. Some people use 3.1415926. It just sort of depends upon how close they want to be, right? Okay, so we use this idea of pi in our formulas. There are two formulas that you will need to be familiar with for a circle. Well, technically three, I guess. The first formula is for the circumference. C, the circumference of a circle, is equal to either diameter times pi, or about 3 times the diameter, or you could say 2 times pi times r, because remember from up above, 2 radii is the same as a diameter. If you need to find the area of a circle, the area of a circle is pi r squared. You might remember that from grade school memes, where somebody drew a pi in a square, right? Okay, so those are the two formulas that you have to be familiar with. If we were still face-to-face, the expectation would be that you had them memorized, but we're not face-to-face, and I cannot control what references you use. So I've given up the control. You need to be familiar with both the perimeter of a circle and the area of a circle. So let's do a few problems. You're going to want a calculator handy. You can probably use the calculator on the computer most of the time. My calculator is the standard one from class. Notice down the first column, there is a pi button. That pi button types just pi into the calculator and gives me a 3.141592654. It actually keeps going inside the calculator, but it just displays this much. If you don't have a pi button on your calculator, you will get results closest to what the program expects if you use 3.14159. So if you use those 5 decimal places. Okay. All right. So we are going to determine the circumference and the area. we're going to give what are known as exact answers, and then we're going to use the pi button, or as it says here, 3.14159, in order to round to the nearest tenth. Okay, so in problem number 17, we have a circle, and they've given us the radius. So when I go to find the circumference, I will use the formula 2 times r times pi. Since I know the radius is 16, I'll do 2 times 16 times pi, or 32 pi centimeters. This is my exact answer. Since I have not typed in a value for pi, saying that the circumference is just 32 times pi is my way of giving an exact answer. Now, this is going to be 32 pi. So 32 times pi is going to give me 100.5 if I round it to the nearest tenth. It's worth noting that if I had done 32 times 3.14, I would have still gotten, in this case, 100.5, but that's not always going to be the case. So it's going to be in your best interest to either use the pi button or 32 times 3.14159 if you're in a situation where you don't have a pi button to use. Good? All right. The area of this circle would be pi times radius squared, or pi times 16 squared. When I square 16, I get 256 pi. This will be centimeters squared. This again is our exact answer. And if I need to round it to the nearest tenth, whoops, where am I going? There we are, 256 times pi. And so to the nearest tenth, that would be 804.2. Okay. Took up a little bit of space there. All right. The other one I wanted to do for sure was number 18. Again, same process, except what they gave us here was not the radius, but rather the diameter. Right? The center would be somewhere along that line. So the circumference would be 2 radii times pi, or we could use the other formula, which is diameter times pi. This would be 7.1 times pi meters. Notice that's just the exact answer. I don't need to do anything else there. And to the nearest tenth, 7.1 pi is 22.3. The area would be pi times the radius squared. Now, they didn't give us the radius here. So you have to deduce, figure out, suss out that 7.1 divided by 2 would be your radius. So I'm going to take 7.1 and I'm going to divide it in 2. I'm going to have a pi times 3.55 squared. If I square that, I'm going to get 12.6025 pi. That's now going to be meters squared. This, again, is my exact answer. If I multiply that by pi, I get 39.6 meters squared as my tenths. Oh, not tenths, tenths. Okay, questions on either of those two? Yeah, correct. If you square the 3.55, you get a 12.6025. Don't forget to put the pi back on there. But yeah, I would just keep that whole decimal times pi as my exact answer. Yeah, yep, that's what we're looking for. Okay, Emma's still doing all right? Is there something I can help with? Okay. Am I going at a good pace for you? Okay. All right. So number 19 is going to be like 18. And then 20 will be like 17. So I'm going to leave those two off for you to just sort of follow along. Oh man, Lexi. All right, Lexi still can't hear. Oh, can you hear now? Okay. Well, it's being recorded again, so whatever you missed, you can catch up with in the recording if you need to. Okay? All right. So then we've got 21 and 22, which are just meant to be examples of a half circle. So if we're doing the circumference of this, well, we can't do the circumference, right? Because we don't have all the way around a full circle here. We've basically got sort of the top half of the Pokemon logo. We don't have the whole thing. So we can't use circumference in our normal way. We have to instead recognize that what we have is half the circumference, or 1/2 of the diameter times pi. Since the diameter is 6, half of 6 is 3. So we've got 3 pi plus the straight bit. Right? Because if we're doing the perimeter, if we're doing around the outside, we've got this whole half circle, but we've also got to close this part off. So we've got 3 pi plus 6 centimeters. This is our exact. Now, if I'm typing this in, if I'm figuring this out in my calculator, be careful because that's not going to be 9 times pi. I have to use my order of operations and do 3 times pi first, and then add that 6 in, so that I've got 15.4 centimeters to the nearest tenth. Area is not this complicated. In terms of area, we're just covering that of half a circle. So the area would just be half of pi times radius squared. Since the whole thing is 6, the radius would be half of that at 3. So 1/2 times pi times 3 squared. Now, to get the exact answer here, I'm going to ignore the pi for a minute, and I'm going to use my calculator to do 1/2 times 3 squared. And do you see how that's going to give me 4.5 right away? So that's going to be 4.5 pi centimeters squared. I'm now going to hit times pi, and that's going to be 14.1. Whoops, I didn't do that very well. 14.1 centimeters squared. Okay, questions on that guy? Okay, good. I'm glad. All right, then I wanted to do 23 and 24, which are both composites. Or maybe 23 and 24. And then I'll leave 25 for you guys to do. It's going to be a big number, but it's the same. Okay. So 23 and 24 are both what are known as composite shapes. That means they are different shapes sort of stuck together. My best advice for composite shapes is to figure out what the shapes are made of in their most basic. So looking at circles, rectangles, squares, and triangles. If those are the only 4-ish shapes you had to work with, how would you describe what they used for number 23? I would say there is one square in there, right? That's this bit. Any good. Then somebody put a half circle on the left side and a half circle on the right side. Whoops, I did my left and right backwards, but you get it. So that's what we're going to do with area. I am going to find the area of the one square. If I look at the square, each side is going to be 195. The area of a square is whatever the side is squared, so 195 squared. So if I do 195 squared, that's going to be a big old number, 38,025. So I've got 38,025. Now, what about 2 half circles? I have a half circle here and a half circle there. That's going to be the same as 1/2 and 1/2 is 1/2. Would you agree? So since I have a half circle and a half circle, I don't need to actually calculate a half circle. I can just recognize that 2 half circles would be the same as 1 whole circle at pi r squared. Since my diameter here has to match up with the side of the square, that means my radius would be half of the 195, or 97.5 squared. And this is 9506.25 pi. These would be millimeters, I'm running out of room, squared. This is our exact answer. I know y'all don't like it because it doesn't feel like it's rectified or answered. But if they ask you for the exact answer, you keep pi in that answer. So we would use 3825 plus 9,506.25 pi. To find the exact answer, 38025, whoops, plus 9506.25 pi. $67,889.8 millimeters squared. Alrighty. Okay. For number 24, I don't want to go away there. For number 24, we have a triangle plus a half circle. The area of a triangle from last class is 1/2 times the base times the height. The area of the circle, half circle, would be 1/2 of pi times a radius squared. The base of this triangle is the 9. The height, you recall, has to be able to draw an H. So the height is going to be this drop down, which I do not have. I do, however, have 2 sides. I've got a 15 and a 9, and that's going to be a right. So this one is a bit of a challenge in that I have to use 9 squared plus height squared equals 15 squared. Pythagoras' theorem. 81 plus h squared is 225. Subtracting 81 from both sides, h squared would be 144. Square root on both of those, and h is 12. So now I know this guy is 12. And that helps me because that gives me the height. And if that's 12, I also now know that the radius has to be 6. 1/2 times 9 times 12 is going to give me 54. And 1/2 of 6 squared is going to give me an 18 pi. square inches. This is my exact answer. Why do I always forget the x? EXACT. And then 54 plus 18 pi, which is 110.5 inches squared when rounded to the nearest tenth. All right, questions on that guy? It's not always Pythagorean theorem, but if you're missing something on a triangle, it is often enough, right? Sometimes you can find it sort of a different way, like we did in this guy, right? We didn't need Pythagoras' theorem here. We just had to recognize that if this was 195, all the sides would be kind of thing. Yeah. So it's not necessarily always Pythagoras, but often enough. Okay. All right, guys. I don't know if you've got the sheet in front of y'all, but talk to me. As you look at this one, are there specific ones you want to, we don't have all the time in the world, so if there are specific ones you want to see, please let me know. Well, no, we're finding area, but yeah, it would be. Emma? Okay. Yeah, there's a lot here, right? So again, if you could only use the words circle, square, rectangle, triangle, and you had like a little child in front of you, how would you explain the shaded region on this shape? Okay. They're not triangles though, because this is a curve. We started with a square, but what happened? You got it. Correct. So the area of the square would be side squared minus the area of a circle, which is pi r squared. One of the sides of the square is 12. So that's going to be 12 squared minus pi times, what would the radius of this circle be? Yes. Good. If it's 12 right here on the side, it's going to be 12 from top to bottom, which means our radius has to be a 6 and a 6. So this gives me 144 minus 36 pi. And that is our exact answer. Now, what is that numerically? I'm just going to do 144 minus 36 pi. 30.9 centimeters squared, and that's to the nearest 10. Sure. Yes. Okay. So again, if you could only use the words circle, square, rectangle, triangle, how would you describe the shaded part of 28? What happens in the middle here? Like, how do we make it into a donut? What had to happen in the center? Good. I sometimes call that the little circle, right? So we've got a big circle, and then we need to subtract or minus the little circle. So we're going to do pi radius squared minus pi radius squared, and I might put a little, in math, we sometimes put like a little letter there for the little circle. I put a little L down in my subscript. You can also just remember that it's two different radiuses. You don't necessarily have to use the same notation. So if we're looking at the first circle, what's the radius? Sorry, for the larger circle, what was the radius? Sorry, nope, nope, you're all getting there. See, there we are at the center, right? So to go to the outside of the larger circle, yeah, there you go. And then for the little circle, we start in the center and go to the inside circle. That's a radius of 2. 4 squared is 16. 2 squared is 4. So I've got 16 pi's, and I take away 4 pi's. These I can combine because they are like terms. They both have a pi in them. 12 pi centimeters squared. That is my exact answer. Whoops. This is 37.7 centimeters squared to the nearest 10th. Okay. All right. And there are some composite shapes in the homework for sure. I think there's one on the test. I don't think there's a ton of them. Just the one, I think. But okay. Then we gotta do some volume stuff. Ooh, okay, I got a lot to do in like 40 minutes. All right. Okay, the last section is 6.5. This is volume, and we're gonna do just a little bit of surface area, not a lot. In a different time, I may have spent more time on it, but this term, we're not gonna spend as much time. Okay, so on this page, what you have are the different shapes. The first shape we want you to be familiar with is that of a box. That box could be either what's known as a rectangular solid, where the volume is equal to the length times the width times the height. Or if we get very specific, when all of the sides are the same, we call that a cube. The volume here is that side length cubed. Notice all the sides are the same. Okay. On the right-hand side, we have a rectangular solid, which is a box-like figure. The volume would be equal to the length times the width times the height. And I usually recommend that you put an L, a W, and an H next to each one of those. The funny thing about a box is it doesn't matter which is which. Not really. I don't have a box sitting on my table anymore, but, well, I kind of do. Oh, can I get it? Sure. So here I have a Circumference box. I don't know if you like these. It's not particularly. But the volume of this box, which, by the way, holds my earbuds, the volume of this box does not change if I hold it up this way, doing a length, a width, and a height, or if I hold it this way, doing a length, a width, or a height, or if I hold it this way, doing a length, a width, and a height. No matter which way I hold this particular box, its volume doesn't change. So for a rectangular solid, you can put the length, the width, and the height wherever you want, really. The volume here would be 3 times 5 times 2, which is going to be a 30 centimeters cubed. The second shape we're going to go through is a pyramid. We will only be dealing with square base pyramids and possibly some rectangular based pyramids. So the volume of a pyramid is 1/3 the area of the base, which will be your length times your width, times the height of the solid. Okay. I'm sorry, Lexi. Lexi's just not having good luck with us on this. Okay. So for this particular shape, our length and our width would be on the base. So there's our length, there's our width, and then the height would be the 9. So we'd have a 1/3, 4 by 4 by 9, or a 48 centimeters cubed. The volume of the 3 other shapes you need to be familiar with. The third one is a cylinder. A cylinder is basically like a soup can. This is also, the volume is found by taking the area of the base, which for a cylinder is going to be a circle. So we're going to do pi radius squared times the height In this particular diagram, we see we have a diameter of 60, which means our R value or radius would be 30. So we're going to have a pi times 30 squared times a height of 125. So to get an exact answer, I'm going to square the 30 and multiply that by 125. And my exact answer would be 112,500 pi meters cubed. That would be the exact answer. Or 353,429.2 meters squared to the nearest tenth, or cube, sorry. All right, fourth figure is that of a cone. Volume of a cone is almost the volume of a pyramid. It's a 1/3, but then our base is a circle, so we want to use the pi r squared again, times the height. The height is in the center, just like it was in the pyramid. So our height is 24. Our radius would be half of the 20. So 10 squared times 24. And again, since we have a pi in here, we could be asked for an exact answer. So to get an exact answer, I'm going to use my fraction button for 1/3, and then I'm going to do times 10 squared times 24. And that gives me an 800 pi centimeters cubed. I'm going to multiply that 800 by pi to get that that is 2,513.3 centimeters cubed if we're going to the nearest tenth. The last volume formula is that of a sphere. The volume formula for a sphere is 4/3 pi times your radius cubed. The radius in this particular shape comes from the center of the sphere to the outside shell of that sphere. So in this case, it is 10. So we're going to have 4/3 pi times 10 cubed. And again, anytime we have a pi in there, they could ask us for the exact answer. So I'm going to use my fraction button for 4/3 times 10 to the third. And they're going to give me a weird decimal. Here's, oh, sorry. Oh, okay. Hey, Les. So they're not, yeah. Oh, I understand. I'm sorry it's been such a trial for you. Uh, are you in, are you at home someplace? Are you in the area where? Oh, no, I get it. My phone is Sprint. It doesn't work at my parents'. They live right by Cedar Creek. Yep. All right. No, it's fine. It's fine. All right. So to finish this guy off, for most of your WebAssign or most of your MyLab stuff, they're not going to take this answer. They're not going to take 100 or 1,333.333. They're not going to take that. So you're going to have to look at this and 4/3 pi, 10 to the third power is 1,000. So you're going to have to see this as 4,000 over 3 times pi. That's going to be your exact answer. Yeah. Or yeah, that's where I got the 4,000 from. And then it would be over 3. And just leave it. Don't do this calculation to get the 1,333.33. Don't do that because your calculator will usually just put it into decimal, which they won't take as an exact answer because you have to round it. There's just no way. I mean, it's fine if you don't have to give an exact answer, but if they want the exact answer, they're going to want like an improper fraction. Okay, Emma, Cole, good? Emma, am I completely overwhelming you? Okay. All right. I'm trying to stay calm, clear, and concise for you. Okay. All right. So problems 5 through 14 are just practice in all of the different shapes. Once you've identified the shape, just matching it to its formula and running it through. So if we're looking at problem number 5, this is a rectangular solid. The volume would be equal to the length times the width times the height, or 3 times 3 times 4, which is 36 inches cubed. Volume is always inches cubed. Problem number 7 should be recognized as a pyramid. The volume on a pyramid is 1/3 the area of your base, which is 5 times 7, times the height of your solid, which is listed here as 15. So I believe this is 175. Check my math on my calculator. So 5 times 7 times 15 is 1/3. Yep, 175. And this will then be yards cubed. Problem number 9 is a cylinder. The volume on a cylinder is the area of the base, which is that circle, multiplied by a height of 6. So this is going to be pi times 5 squared times 6. To get an exact answer, I'm going to do the 5 squared times 6 to get 150, keeping the pi in the exact answer. If I multiply 150 by the pi, I get 471.2. These would be centimeters cubed, by the way, to the nearest tenth. Okay, problem number 11 is a cone. The volume on a cone is 1/3 the area of the base. Circle, pi times radius squared times the height of this cone. Our radius here is a 4. The height is 9. So if I need an exact answer, I'm going to do 1/3 times 4 squared times 9. So I have a 48 pi meters cubed. I multiply that by pi, I get 150.8 for the nearest tenth. And then in problem number 13, we have a sphere. The volume there is 4/3 pi times your radius cubed. Or 4/3 pi times 6 cubed. I'm just going to use 4/3 times 6 cubed, and I'm going to hope it works out. 288 pi. And that's going to be meters cubed for my exact answer. Whoops, sorry, I'm off screen. 904.8. The nearest tenth. Okay. Doing the left side there should set you up to be able to do the right side for practice, all right? Any questions? Yeah. Yes. For number 10, the radius would be half of the 24, which is 12. You're welcome. Okay. All right. So then the other part on this is some composite shapes. But if I'm honest, I think I'm going to just pull the composite shapes off. I'll double check to see if they're there on the test. They might be on the assignment, but I think I'm going to pull them off the test. I don't remember if I did or not. Yeah. I still want you to do them on the assignment. I just don't think I'm going to test on them right now. Right? So the idea with these, remember how we did the composite shapes and I gave you like those 4 words to choose from? Yeah. Yeah. So if all you had for this was a box, a cylinder, a pyramid, a cone, or a sphere, how would you describe the shape in number 15? You don't have the word square. Okay? Just one box? Yeah. Yeah, I would say that if you had to recreate this, you would probably take one box and put it up and down, right? And then you would take a second box and put it on the bottom here like for an L shape. So the total volume would be that of the box that's pink added to the box that's orange. So for the pink box, can you figure out the length, the width, and the height? How long does that have to be? Nope. It's tempting to always put it in half, but it's not going to be in half. Yes. Well, 6 would be the whole thing. So that leaves 2 for the pink. What about the width of that pink box? So if I'm thinking of the width is going all the way back, right? Even though we didn't see it, even though it's hiding there, that would be the same as this one, which has to be the same as this one, which has to be the same as this one, which has to be, yeah, so that's going to be a 6. And then the height of this box is 5. So that's going to be 60. And then for the orange box, we could still do length and width and height. But the length would just be that part, which is 4. The width would be the same. And the height is the 2. So that's going to give us 48. And when I add them together, I have 108 centimeters cubed. You could also split number 16 into 2 boxes. Or you could split it into 3. People will split them all different kinds of ways, right? I see right away I could do a top box and a bottom box, right? Like I'm wrapping gifts, one goes on top of the other. But I have seen people do this where they just did like an end piece, a tower in the middle, and then the other end piece, right? So they split it down that way. Either way is fine. You should get the same answer no matter which way you split it. So that shouldn't be the problem. Okay. What about number 18 is one that comes up a lot. And if you can only use these 5 words again, the box, the cylinder, the pyramid, the cone, and the sphere, how would you describe number 18? There you go. We've got a cylinder on the bottom and a half sphere on the top. So now I know which formulas to reference. The volume formula for a cylinder is pi times radius squared times height. So pi times radius squared. Do you know what the radius is on this cylinder? Right. 76 would be how tall it is. So 76 would be my height. But we do know the whole thing is 102, right? Do you want to divide by 76? What do you want to do? The part that's missing goes from the top of the sphere to the center of that cylinder. How long does that have to be? 102 is the whole thing. Well, 26 would be the difference here, right? And if that's got to be from the center of the sphere to the top, that's got to be a radius for the sphere. But here's the thing, the sphere fits perfectly on that cylinder. So it's got to be 26 everywhere for the radius of that sphere. So this guy also has to be 26. So 26 has to be the radius of our cylinder, and it has to be the radius of the sphere. 26 times 76 is 1,000, or 1976 pi, plus the volume of the sphere here would be 1/2 of 4/3 times pi radius cubed, or 1/2 times 4/3 times pi times 26 cubed. Oh, this is not going to be a fun number. Okay, 1/2 times 4/3 times 26 cubed. Yeah. 717 and 1/3 pi. Is it okay that I did that and 1/3 pi? Because I've got a 0.333333, that would be my 1/3. So I've got to add 11717 and 1/3 to 1976. And that's going to give me 13,693 and 1/3. Oops, 1/3 pi. Ugh, these were not nice numbers. There we go. So to the nearest tenth, I'm getting 43,018.9 millimeters cubed. Yeah. That's for that whole thing. Whew. Not a whole lot of these I'm going to give you. There's a lot in there. But I won't give you a whole lot of those. And I believe I've pulled them off the test. So I'll double check that. Still got to do the basic ones though. Surface area. We don't really have enough time for surface area. I think for surface area, the one you really kind of want to watch out for is this guy. And its formula is right there. Oh, the sparkly is getting there. So this is the surface area formula. Says that we would use 2 of the length times width plus 2 of the length times height plus 2 of the width times height. So essentially, it's just like you're pasting the 6 sides on a box, right? So you'd have the top and the bottom, you'd have the front and the back, and then you'd have the left or the left and the right, kind of. And that's what we're doing with surface area, is we're just finding each side there. So once you know what your length, your width, and your height are, you can just put those numbers in and calculate this sucker out. So this would be 2 times 5 times 8 plus 2 times 5 times 3 plus 2 times 8 times 3. $80 plus 30 plus 48. $158, and this will be yards squared because it's surface area. The area is squared. The surface area of a cube is just like that of a rectangular solid, only each one of the sides are the same. So you can just find the area of one side and multiply it by 6. That's why the formula here is 6 sides squared. Yep. That's exactly what you would do in this last one. So the surface area would be 6 times your side squared, or 6 times 5 squared, which is 150 inches squared. And then 21 is it's one of my favorites, actually. 21 is the surface area of a cylinder. And a cylinder has 3 surfaces. Your top surface, think of a soup can, is a circle. Your bottom surface is also a circle. But deconstructed, this third surface is actually a rectangle. Think about the way you pull toilet paper off a roll or paper towel, right? The shape of paper towel is actually a cylinder, but when you pull it off of the roll, you get a rectangle. The side of this rectangle has to be 2 pi r, or the circumference of that circle. The bottom side also has to be 2 pi r, or the circumference of this circle. The distance between those 2 circles is the height. Now, you will have a circle on top and a circle on the bottom. So the surface area here is 2 times pi r squared. That gives me my top circle and my bottom circle. And then my rectangle is the length, 2 pi r, multiplied by the height. You know from this diagram that your radius is 6 and your height is h. So this would be 2 times pi times 6 squared plus 2 times pi times 6 times 8, which is 72 pi's plus 96 pi's, for a total of 168 centimeters squared, which would be 527.8 when we're looking at the nearest tenth. Whew. All righty. Any last minute questions for me? Does everybody have the notes they need off of that? Okay. Well, I'm hoping that it processes and everything gets up there by tomorrow. But, you know, with everybody on the web these days, my upload speeds are way slower than they were previously. So we'll just have to let it upload overnight and hope it all works out okay. All right. Emma, any last minute questions from you? Okay. All right. And Cole, you said you were okay? Tuesday at midnight. I think at midnight. Yeah, pretty sure midnight. Just chapter 5 and 6. There is a review available on my lab as well. Let me just double check that. Yeah, there's a geometry review that I have due on the 31st at 5:05, so before class. And then the test. What time do I have the test? Yep, the test is on my lab. Yep, 25 questions. It opens tonight. It's not timed. Um, it's not locked behind a browser or anything. The only thing that you need to know about taking this test is that if you log out of it, you can't re-answer any of the questions you attempted. Okay? Right. Or, if you need to walk away from it, that's fine. Just know that you can't figure something out and go back and change an answer. Okay? No, you can, but if you log out of everything, you stop the test and log out, you can't go back. Okay. Yeah. Yeah, and yeah, you'll have to watch out for that, for it to auto timeout or anything. But yeah. Okay. Anything else? All right. You guys have a good night and a good weekend. Reach out if you need anything, okay? All right. Thank you guys.